Continuing on with section 2.5, in class we talked about looking at trinomials and determining whether or not they were perfect square trinomials. What we'll do now to convert from standard form to vertex form is we'll take any polynomial and have to make it a perfect square using what's called complete the square as our process. When converting from standard form to vertex form, the completing the square process is different if a equals 1 in front of x squared or if a equals a different number. So today we'll do the method when a equals 1. That's going to be the easier of the two options. What we'll be looking at then is y equals just plain x squared plus bx plus c. That's our standard form. The first thing you want to do is just set x squared plus bx plus c equal to 0, and then move c over. That would leave x squared plus bx on one side. C, you'd move it to the opposite side. To do the complete the square process, what you're going to do is take half of whatever b is, whether it's positive or negative. Okay, easy enough. Step 3, take the answer you got in step 2 and square it. Now you may have a negative b value, you may have a positive b value. Whenever you square it, you'll always have a positive number in step 3. Step 4, add that to each side. And what you've now done in that step is created a perfect square trinomial with the x squared and bx term. So then what you'll want to do is factor and write as a perfect square. And there you go. That's completing the square. Let's see how this works. Convert f of x equals x squared plus 8x plus 5 to vertex form by completing the square. Following our steps, step 1 is to just set the equation equal to 0 and move c to the other side. X squared plus 8x plus 5 equals 0. If I move c to the other side, I'm going to subtract it. And that gives us x squared plus 8x equals negative 5. Step 2, take half of b. Well, b is 8, and half of 8 is 4. That's step 2. Step 3, square that number. 4 squared is 16. So far the steps should be pretty easy to follow. Step 4, add that to each side. If you add it to the left, you end up with x squared plus 8x plus 16. On the right, you have negative 5 plus 16. If you add the same thing to each side of an equation, you keep the equation balanced. Step 5 is to factor. Two numbers that multiply to get positive 16 and add to get 8 are 4 and 4. So this would factor into x plus 4 and x plus 4. On the right-hand side, negative 5 plus 16 is 11. Now, if you have the same parenthesis written twice, that's a perfect square. X plus 4 squared equals 11. This is a good stopping point. From here, you can do a variety of things like convert to vertex form or solve. So if we're going to convert to vertex form, we're going to move 11 over, and then it equals 0. We have x squared. Oops, no we don't. Hang on. I was one step ahead of myself there. Sorry. We have x plus 4 squared minus, I'll figure it out eventually, minus 11 equals 0. But to write it in vertex form, instead of equaling 0, we'll set it equal to what it was at the very beginning. It was f of x. So your final answer is going to be f of x equals x plus 4 squared minus 11. That would be vertex form. Another way we can use completing the square would be to solve a quadratic function. To solve by completing the square, you're going to do the 5 steps. So complete steps 1 through 5, and then just take the square root of each side and simplify. Kind of like we did on our worksheet for 2.4. And that's how you can solve using this method. It says solve by completing the square. It's already set equal to 0, so that's in step 1. I'm going to move 3 to the other side by subtracting it. And I like to write the x squared on the left-hand side, but it really doesn't matter. You can keep it on the right-hand side if you'd like. And I'll move negative 3 over to the right. Step 2, take half of b. And now notice, you guys, b equals negative 2. So if we take half of negative 2, we get negative 1. Step 3, square that answer. Negative 1 squared is positive 1. Step 4, add that to each side. So add that on the left, and that would give us x squared minus 2x plus 1. On the right, negative 3 plus 1 again. Step 5, factor. With a equaling 1, we need 2 numbers that multiply to get positive 1, but add again to get that negative 2. Well, the only way you can get 1 is 1 times itself. But if we want to add to get negative 2, we'll do negative 1 and negative 1. On the right, negative 3 plus 1 is negative 2. Write the left-hand side as a perfect square. X minus 1 squared equals negative 2. There are steps 1 through 5. When you get to this point, this looks like some of the examples from the 2.4 worksheet. Now take the square root of each side to cancel out the squared power. But we have to take the square root of each side to cancel out the power of 2. That would give us x minus 1 on the left, although I guess we don't really need the parentheses, do we? Since it cancels out the radical. X minus 1 on the left. Notice on the right we took a square root, so we have to think about our rules for solving quadratics. We need a plus or minus, and we need to take out the negative out in front for this one by putting I in front of the radical. That makes negative 2 positive 2. The square root of 2 doesn't reduce any further, so we can leave it in that form. Last but not least, get x by itself. We'll add 1 to each side. And we get x equals 1 plus or minus I radical 2. So you'll notice if you look at x squared minus 2x plus 3, that actually didn't factor. So we wouldn't have been able to factor to solve. Therefore, completing the square helped us. That's going to be as far as we go today for the 2.5 Day 1 lesson. The assignment is on Pearson, and that will be due on Monday. Have a good weekend.